So we had a chance to talk about data layer, the primary mover of data layer, Michael Taylor. But I feel like there may be more of a discussion that we could have regarding data layer and what it really is. And I think there is possibility for easy confusion with stuff like the anonymous internet, Tor, some other stuff. So thought it'd be a good chance for us to talk a little bit more about data layer, continue the conversation in case there's more questions that really exist about how this technology works and what it can be used for. So, Lucas, maybe we should just start with, do you feel like you had a good understanding of what data layer is, or should I start by maybe describing it the way that I would describe it?
I would love it if you would describe it how you would describe it, because um, I had a lot of questions, but I wanted to focus on what Michael's views were yesterday, and not pester him with questions that were probably going to. Yeah, tell me what you think of when you think of what data layer is.
Okay. So the first thing that we need to make sure we firmly understand is what a blockchain is and what something like Chia or Bitcoin is. So these are just databases. They're really bad databases. I usually like to pedantically say something that shocks people, especially in the world of Web3 and blockchain, to say like it's a really shitty database that takes a really long time to do anything. And it's kind of a joke, but it's meant to get the attention of people who aren't really thinking about what these technologies fundamentally are. And so it really just is a database. Like that's the mechanism that we use to store the data for the blockchain fundamentally. Every single, coin, blockchain, whatever, fundamentally stores its data as a database. So Chia uses SQLite database. Um, Bitcoin uses flat files, but ultimately they're all just a way to store structured data. And what they do is they say if you're going to be allowed to make a change to the database, then you have to have done something special. And in Bitcoin, that special thing that you've had to have done is find a special input value that results in a SHA-256 hash with a preceding number of zeros that meets the current difficulty rating, and that's fundamentally what you have to do. And in Chia, you're doing something slightly similar. You have to solve a special kind of math equation, and it has to meet a certain value. And then if you can make a change to the database. What data layer is doing is it's allowing you to put data next to that database. And I call it data adjacency. So one of the things that we've been struggling with in the world of Ethereum and Bitcoin and whatever is that if you want to have bigger data, stuff like images, and the first use case for this was stuff like NFTs, right? You had Bored Apes and you had all the rest of this stuff, and you had CryptoPunks. And fundamentally, what you're trying to do with that is you're trying to make a special kind of a coin that meets the standards of what can go into the blockchain, and then you want to put some extra data in there. And what has been happening is you'll point to something like IPFS, and or you'll point to just some URL, and that's where the image is. The trouble with any of that kind of stuff is if you put in a URL and the thing that is supposed to resolve that URL isn't maintained, then you end up with a dead link. So this happens frequently on the internet. Is you have some link and then somebody decides to shut something down, and then all those links are broken. So unless you captured the thing that resolved on the other side of that URL, that link is just broken and dead, and you can't really tell what the thing that linked to it was supposed to be because you've lost that data. So it's how the internet can rot. That's how it's sometimes referred to. So what data layer is allowing you to do is put data next to the chain and then have a mechanism of providing for the availability of that data. And that's partially like what IPFS was intending to do. Was you have this interplanetary file system, and you're trying to distribute data across the entire internet in a distributed fashion, and then be able to index it and resurrect that data if you need to, because it has a very specific hash. So you could know that if somebody says, oh, hey, this was the thing that was supposed to be resolved to an IPFS, you could check it. You could say, well, I don't know for sure unless I take whatever image you're showing me and compute the hash function on it, and then compare it with what was supposed to be an IPFS. And if it matches, then I know I've got the right thing. So it's possible to resurrect data and know that it was correct. On the normal internet, that's not really possible. We've got a hyperlink, but it doesn't have a hash. So that's fundamentally what you're doing with data layer is you're making a special kind of a coin, and with that special kind of a coin, you're saying here is the correct state of the data, and if you get that data, you can check it. So it allows you to do something which has been kind of tricky on the internet, which is to know that you have the right data and it hasn't been tampered with. And if you have an immutable database, which is what we've got in blockchains, then putting a hash in that immutable database allows you to very concretely know that you have the correct thing. So when Michael started talking about, well, this is a way to do the distribution of software, it solves a really fundamental problem, which is, how do I know I have the right software and it hasn't been messed with? You know, that somebody didn't, you know, goof around with it in some way. And this happens frequently where you'll get some kind of a flaw in the software, and then you'll not end up with the exact thing that the software developer intended for you to have. And so now this mechanism of getting the software actually has a vulnerability in it, and then you get something which is tainted in some way. If you hash the application data, then you can check it against that hash and you can know that you got the right thing. So this is like the fundamental technology that we're talking about here, which is the ability to put some data next to the blockchain, put pointers into the blockchain, put hashes of the data that you care about. So that way, when you've gotten the data that's next to the blockchain, you can be sure that it's the right stuff. So then the next part of the technology is, well, how do you actually get access to the data? How do you make the data available? And that's what was coupled together in this technology that Chia called data layer. And it was used first to do the climate action data trust. And just to get another thing on the screen, I'll throw the IPFS details up so we can have that up. Does that first make some sense?
Yes, that does. Can you? I mean, even Michael also mentioned HTTP, Hypertext Transfer Protocol, and I think maybe it's important to also go back to that aspect of. I don't know. I don't know if we want to go further back, but the notion that the IPFS was content based versus location based, and this notion, because also what we're trying to, or what some people are looking for, is the distribution of information so that it cannot be censored by a government or taken down. And so when you have a protocol that is verifying the authority of the information based on the location of its source, the next step was, well, let's verify the location by the location and the copies of that thereof. And so, because I'm not as well versed in IPFS, I was aware of it and knew that data layer was building on the concept of IPFS and tying that to Chia because also the consensus, the proof of space of time in Chia gives it a networked storage system in the hard drives that support Chia. So I just wanted to bring that up, and yeah. So, but everything else that you're saying, Grant, making a lot of sense, and but continue on. Thanks for flashing up some HTTP for me.
Well, okay, so if we just look at the definition of IPFS, right, it's talking about how you address content, and you're doing so by the actual hash of the data, right? So these are similar types of technology, and IPFS, it's a way to get access to the data. It's a way to store data and make it available, and it uses the same kind of technology that BitTorrent does. And this is why when we were talking about data layer, I said, "Gosh, it sure seems like we've already solved this problem in some sense." Because if you look at some of the ways that data layer is being implemented right now, they're talking about a decentralized internet and things like decentralized internet gateways, which is saying, well, how do I know who has the data, right? How do I know where to go to get access to it? And is it broken up into chunks? And how does that work? So BitTorrent was, I think, probably the premier or like one of the first, big file sharing client things that ever existed that was peer to peer. It's even on that chart of how do we get from where we were in the world of the internet to something like Bitcoin, because it was a peer-to-peer file sharing technology, right? It was a way that you could get access to files by saying, well, I know the specifics of the type of file that I'm trying to get, and how can I chunk it into pieces and sort of have this peer-to-peer swarm that would allow me to get access to the data. It was a decentralized type of internet, but it didn't have a lot of stuff that we would commonly associate with the internet, which is stuff like this URL, right? Like if I want to go get access to Wikipedia, I don't type in some hash file or even have a list of hash files. I have like these friendly names, and this friendly name, there's technology behind this that allows me to find the right machine to talk to, right? There's a name resolution system, so that's DNS. So you register names, those names have name servers, and then ultimately it tells you somewhere to go get the content, and then your machine shows you this URL, but under the covers and under the hood, it's actually going and talking to some IP address, and that IP address, it starts talking over a protocol called HTTP, because that's what we're doing here. So if I click on this a couple times, you can see the protocol that we're talking is HTTPS. So this is the secure version of HTTP. I'm resolving it to some machine, and I'm getting access to it. So that DNS resolution thing, that's this part of the internet that is required to go find content. And so what data layer is doing, what Michael and crew have done, is they're saying, well, instead of going to DNS, just go to the blockchain and ask the blockchain where the data is, and then you can go get access to it from there. So that's this concept of the the dig node, the decentralized internet gateway. Instead of going to DNS and finding a machine and asking where it's going to be, it says, well, I'm publishing the fact that I'm a sharer of this data on the blockchain. And so you can look at the blockchain, it tells you where you can go to access that machine, and then you can get the data from there. So it's this way of saying, here's the data I'm publishing, and here's a way of finding it and using the blockchain for all of that infrastructure instead of using DNS and the rest of this stuff that was built. So it's saying we have a distributed database. Let's just start using it as a distributed database. And then let's put some data next to it, and then have a mechanism whereby we can have people connect to the various publishers of data to get access to whatever it is that's being published via the blockchain. Because it's a distributed peer-to-peer blockchain, that is Chia, similar to Bitcoin, that database can be written to as long as you've got Chia. So as long as you have some ability to buy block space, you can just write stuff into there instead of doing things like registering a domain and putting name servers up and telling people about where your data is via these common HTTP things. We can just use the blockchain to advertise data. And so that's fundamentally what data layer is.
Would you roll your eyes if I said so? So Chia, it's looking at Chia or the blockchain of Chia as a new telephone book, as opposed to whoever is the authority behind DNSs and what we use now with the HTTP system?
Right, because DNS is what allows you to find other machines. So it's like when we talk about BitTorrent and how you find machines that have access to the data, right? They have a mechanism of connecting to a swarm. So BitTorrent is very centric on like a specific file. So if you're trying to share a particular file and you know that that file is out there on the internet somehow, you can get access to the swarm and then you can start getting that file from the swarm. And you don't do things like try to connect to DNS to find it. Like you don't register a machine, rather you have a way to say, here's this file that I'm trying to share, and here's a way to get access to other clients in the swarm. And so the swarm is there are people who are trying to download the file and they simultaneously are uploading the file. So that was the big advancement in this, is that everybody who's trying to get access to the data is also serving the data, and so it was feeding on itself. So when you say phone book, yeah, that's a good analogy for what DNS is, because DNS is a way to find somebody's phone number, right? You know their name, you know something about the name. There's this friendly thing like wikipedia.org, but you don't know what machine is supposed to be serving up that data. So you go to the phone book to find the IP address. And so similarly to how BitTorrent gave you a different way of finding machines that could give you the data, Datalayer is saying, well, we can use the Chia blockchain to find machines that have the data.
Um, it, it, and when I was the day that I turned 16 years old, not to go back that far, but the day that I turned 16 years old, I actually started working for a bulletin board system, and that's part of, I guess, when I think about the internet and how it starts. When I worked for a bulletin board system, it was a computer that was tied to a modem that was tied to a phone line, and you would literally call the phone number to get the information off of that computer. So that's part of why I think of it in such a way, because then we saw the growth of www protocol, the World Wide Web, HTTP, and these this sort of grand network. But it's never, I haven't really followed who is in control of it. But that's something that I sometimes wonder, like, who is control of the great phone book that is the World Wide Web that we use. Because now you can type in an address instead, but you're not typing in a physical phone number to go to these sources of information.
Well, HTTP isn't the only protocol for transferring stuff. So during the early days of the internet, when things were still being sorted out, we were experimenting with different types of technologies for how to network computers together. We were also experimenting with different ways to have machines talk to each other. So if you're going to have two machines talk to each other, they do it via a protocol. So we've talked about things like syntax and protocol, and these things all have very specific meaning in the world of computers. And so a protocol is a way for two machines to agree to speak in a structured way to each other. And so HTTP is one of them, Hypertext Transfer Protocol, and then Gopher was another one. And then there are other ones that are built on top of the common networking stack. So you might have experienced FTP, or you might have heard of UDP as a different networking interface layer. So these things are all different ways that we can have computers talk to each other, and they're part of what's called the layer 7 structure. There are these different stacks, and it's a way to abstract different pieces so that when you're trying to sort out these different protocols, you could have maybe you're wirelessly connecting, or you're doing so over an Ethernet cable, and then what is the thing that's actually being exchanged over these different types of packets. And ultimately you roll up to the highest levels, which is usually something like HTTP. And so that's how we would transfer data around, because it's a very common way to do things is HTTP, but it's possible to do different types of protocols. And so BitTorrent is a way to do file sharing. It's a way to discover what machines are doing stuff. Um, and the transfer mechanisms are specific to each of these different protocols. So it's important to remember that there's lots of different ways that computers can fundamentally move bits around on the internet. And so for data layer, they're still in a lot of ways leveraging HTTP, but it's not necessary that it would work that way. And so part of the discussion that we had yesterday was, okay, if you have that machine that's over there, well, how are you actually getting access to the data? Like, what are you really doing here? So it's entirely possible that you could conceive of a data layer mechanism where instead of saying, I'm going to tell people about a specific set of machines that have the data, you could say, here's the BitTorrent swarm that's going to serve up the data that's pointed to on the blockchain. So there's like a couple different pieces of technology here. And what's the most recent development that they've changed is that first one. Like, how do you actually just get the data onto the Chia blockchain, and how does that work? And the thing that's next to that is, how do you get access to the machines that are actually serving up that data? So they're disjoint. They're two different pieces. And so we were really talking about three different parts of the technology. The first one being, what are you actually putting on chain? The next one is, how do you get access to the data? And then the third one was the marketplace under which you would pay to have a certain number of people constantly participating in the publishing of that data, instead of going to something like AWS and paying for Amazon to store your data.
And this is where we got into the conversation about browsers, because you know, I don't you know, before there also was BitTorrent. You know, the first that peer-to-peer that I experienced was Napster, and and I enjoyed your explanation of the chunking of the data. Um, is that really the innovation that BitTorrent had over Napster, was that it was chunking data, it was breaking up the files so that that a song, because this was a fight over music largely, that a song couldn't be tracked down to one computer, and that person be uh, responsible for the dissemination of all of that information.
Napster was a way to do file sharing and like peer-to-peer file sharing, but it had a centralized component to it. The thing that was different for BitTorrent is that BitTorrent had no centralized component. As long as you could get this weird string of characters, right, which ultimately in the very, I don't know, I guess, decentralized way that BitTorrent ended up working, you had these things called magnet links. And as long as you had one of those links, then you could get access to the swarm. So what you had was these places where you could just put these links to the data. They didn't actually contain the data. So there was this gray area of how you could have a site that all it did was have these magnet links and have a description of what was supposed to be on the other side of that. And that's the other thing that Michael was talking about was, what are we actually putting on chain? We're putting like a description and a name and whatever. And so you can think of this database that is the Chia blockchain has the ability to store all of the data like what the Pirate Bay stored, because they were just storing like a link to the data. And then you would have to use the link to connect to the swarm to get access to the data. So the data didn't live inside the database, but rather it lived in the swarm that was propagating it. But the problem with something like that is, if you try to connect to the swarm and nobody's publishing the data, you can't get the data. So if the swarm has no seeders, you're stuck. You can't get the data that it was pointing to. And so that's what the marketplace was for, is to say, well, I care about this data, or somebody cares about this data, and I'm paying people to continuously be seeders on that set of data. So Napster is a little bit different because it had a centralized component, and that's why they could go attack it. But BitTorrent was like a completely peer-to-peer system, and it was very hard to say that there was any centralized anything, because it was completely decentralized. It was one of the most successful first decentralized protocols, and it really inspired a lot of people, having seen how that could work, to say, well, we should build more technology that works this way.
Well, when you talk about seeders and magnet links, it makes me think of that the data layer is providing a place and a protocol for ensuring seeders, and then when you talk about magnet links, it puts me in mind of offer files and their relationship in Chia. Is that sort of a fair correlation?
Offer files. Um, I'm not sure they're related, but ask the question one more time. Let me see if I can really
Well,
understand it.
because with the magnet links, it gave you a place to move to a directory to move like from you could list a directory of the things that were available, and then you followed those to information. And with offer files in Chia, you can do the same thing. And so when you said the Pirate Bay, it put me in mind of the marketplaces on Chia, Mint Garden, Dexy, and especially like the decentralized nature of Dexy. In some ways, it's like the list of torrents that you could go browse through and follow information back. And then when you think about the data layer as being a protocol and hosting of that information, it's providing a method to both store and follow the links to that information.
So something like the Pirate Bay, like think about what the Pirate Bay was. So yes, I think that that's a good example of something like Dexy, because what is Dexy fundamentally? It really is just a way to resolve a bunch of offer files, right? So Dexy is saying, here's trades that people want to do, and if you have access to that data, then you can do a trade that doesn't have this counterparty risk, right? So if we just think about something like what Dexy is, and I'll just throw it on the screen so we can think about what this is fundamentally doing. So this is the decentralized exchange, right? It's a centralized site. So Dexy.space is this website that exists, and it has a centralized component, right? Like if you attack this DNS host, if this got shut down in some way, then this thing as a decentralized exchange would cease to exist, would cease to function. But if you were to put this website on data layer and then have multiple different people publishing whatever version of this, that would be entirely possible. Like you could do that. So it would be possible, but if you think about how often this is changing, right? Every time you upload a new offer, you would potentially have a different version of the database that you'd have to be looking at. So this thing would be changing a lot. So there's challenges if you're going to try and publish something like this, which is ostensibly trying to happen in real time, um, where it might not be as easy to formulate this into something that would be easily distributed uh, as something that could be delivered via data layer. Now, something like Tibetswap maybe would be a better candidate for this, right? Because if you look at what Tibetswap is fundamentally, this is an interface to trading on Chia, right? It's like Uniswap. And so if you're going to do this, fundamentally, this interface is like a nice GUI that allows you to interact with the blockchain itself. Like it doesn't do anything particularly except give you a window into the the Chia database. Because if this thing is to function, it needs to have the database, or it needs to have a full node next to it. So if you were to consider where you have some kind of a client, and that client has essentially the whole Chia blockchain sitting right next to it, then this thing could function as long as you can get this interface. So you're going to a centralized place via DNS to get access to this application, and then that application is just using the Chia blockchain to do a swap. So if you put this thing into data layer, this thing probably doesn't change that often. And if it was connected to the Chia database via, the full node protocol, then you would have a completely self-contained style internet. And that's why Michael started talking about that, saying, well, in its final form, you really do need to have a client that just is sitting next to the Chia database so that you can deliver things like this application, and then you're in the world of a completely decentralized internet where there is no centralized thing that can be shut down. So an application like this is easy to think about putting on there. An application like this is a little bit trickier, and maybe not a great candidate for this fundamentally, except for maybe this interface. Like maybe this interface doesn't change that often. And so the delivery of the application data itself is maybe a good candidate for data layer. But since this data is changing so fast, you may need to do some extra work to make it real time like you'd want to, because otherwise it's going to move at the speed of the blockchain.
And when you say client, you mean an application that exists on everybody's machines, like something that you download that your computer, your phone uses to communicate directly with the Chia blockchain. That has that language built into it. Like Michael talked about working with a browser. Because a browser, in one way to think about it, is just a client that both works with the internet and with those various protocols that we mentioned earlier.
By client, I mean this like as an abstract kind of a thing. You have these clients, they speak over the internet to some other machine. So if you just have two machines that are in communication with each other, the client is the one who is asking for data, and the server is the one that is giving it to you. So you have this machine which is serving, and this machine that is asking. So it's that fundamental thing. So when you're thinking about like that piece of software, this piece of software that I'm running right here, this is a web browser. So this is the web client. So this client is then going out to Wikipedia, which is the server, and is giving me this data, and then the client renders the data. So what the server gave the client was this page, but this page maybe had a bunch of stuff in it, like this little graphic here. And maybe this graphic is something that you need to ask the server for specifically. So the web page, when I go to client server model.html or whatever this ends up looking like, it has a bunch of hyperlinks in here, and some of them the client, this web browser, knows to go fetch them and resolve them. And there's a way for me to ask this client to render this in a different way. Like I can say, show me this as pure HTML, and it would look like machine readable garbage. And so this is rendering it in a very human readable way. So that's what I mean by client, is something like this.
And in that, Michael also mentioned the standardization of. So we could have, I guess, like somebody disseminating software that is a client that's devoted to Chia, but eventually, hopefully, we have browsers in which instead of HTTP:// you have Chia :// and maybe :0 brings you to something like Tibetswap, and :1 brings you to something like Dexy, that you can browse offers or view NFTs that exist on the chain. Is that sort of the goal that we imagine?
So something like Chia : would be a way to use some kind of a naming system within Chia that is a different DNS. But when you fundamentally get down to like how do these machines talk to each other, you could still use data layer to do HTTP. Like there's nothing stopping you from using the existing protocol to do something like that. Just as in in an NFT, there's nothing stopping us from pointing an NFT at IPFS or at a regular old, web URL, like something like this graphic, right? Like if I wanted to use this graphic in an NFT, I could use this data that's served up by Wikipedia, and it's as resilient and as long-lived as Wikipedia is. But if Wikipedia ever stopped existing, right? So like if I say, open this image in new tab, then that image right there, see, it's got this long blah 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 whatever upload Wikimedia. But if this Wikimedia thing ever goes away, then this thing would just be busted, and you'd never be able to tell what that NFT was supposed to be pointing at. You wouldn't know it's supposed to be this little book icon with this little question mark on it. So data layer doesn't really tell you what protocol you need to speak. And this idea of the names that exist here are DNS. So if you use some different mechanism for naming stuff, then that's why you would need some Chia thing, because you would be speaking not HTTP, but some other protocol. So there's this differentiation of like what the protocol is versus like what exists after this protocol. Like this naming thing has to do with how DNS works, and this part is the protocol piece, and that says how do you actually talk to the other machine that's on the other side of that.
Well, and I guess when I think about using a Chia as the protocol to begin with it, because I was thinking that it would bring into the Chia blockchain the the assignment of DNS names, DNS hosting, because as if you're using HTTPS if you're using DNS registry for what those are, doesn't that exist somewhere? I mean, probably yes, an agreement, but I mean, you could go out and buy a website. Who are you buying it from?
Oh, who are you doing the name registration with?
Yeah, who like where who currently does is the god of name registrations on the internet?
Well, it's a federated mechanism. So there's a lot of different places that you can register names, and that's why there are things called name servers. So I don't know, maybe we should just pull up a graphic for how that works. I mean, we're just starting to get into really just the guts of the internet and how does it work. So DNS works like this. So there's let's see if there's any graphic in here. Yeah. So there's these different like top level pieces, right? So .com and .net, and now there's just legions of different top level domains like .link and .xxx and .xyz. So there's a lot of these different top level domains, and whoever owns those top level domains is ultimately who's in control of that specific namespace. So it's the TLD is who is in control of that.
And TLD I see is under ICANN,
Yeah.
and ICANN is sort of the group of I don't know, people who were using the internet to have come together to form the I don't know, like the original internet consensus mechanism, right? It was.
Yeah, it's this international organization that allows you to resolve between names and machines that are going to facilitate the publishing of data that's a result of that name.
And so can Chia become, and I guess when I think about Chia, like even replacing some of the functions that are agreements that are, that ICANN maybe lists, what the agreement is for the DNS name system, the .coms, the various aspects of agreement of communication. When I think about maybe putting that into a blockchain, or it having its own agreed upon syntax, does that begin to address like DDoS attacks? Because if you have something that is out and part of this confederation of agreement, then yes, it may be distributed and decentralized, but it's still open to it's still open to what seems to me to be one of the top insecurities of the internet is just routing a bunch of traffic there to take it down.
Yeah, it doesn't. I don't think it really speaks to solving that. Like it doesn't fundamentally because
Really?
no, because if you think about like what they're doing, right? A decentralized internet gateway coin, right? That thing that you're putting on chain just says here's a list of people who have the data, and it doesn't say anything about like how to protect those machines from getting flooded with too many requests for the data that you're interested in.
Well, this is why I was interested in the spin bundles, because does it not cost mojos to for clients to discuss or use that coin, or could there not be a cost that was added in to access certain information on it?
Well, if you're going to put data into the blockchain, it's either readable or it isn't, right? If you encrypt the data in some fashion, or if you make it opaque, then it's hard to think about how you might use that to do something reasonable. The way that I understand, what they're planning on doing with the decentralized internet gateways is they're just publishing a list of the machines that have access to the data, and the way that you put that list of machines into the blockchain is you just spend a coin that anybody can spend. So you just say, I'm also publishing this data. And that's where that whole Oracle thing came into play. It said, if you're found to have been publishing this data over a period of time, then you'll get paid for doing that. But it doesn't stop a malicious actor from saying, well, let's try to make sure that nobody can get access to that data. And we're just going to, flood each of those machines with tons and tons of traffic so that nobody can talk to those machines to get access to the data they're interested in. So I'm not sure how you could use anything that exists within Chia to fundamentally thwart that, unless you were to put some kind of a cost associated with actually speaking to the machine. So you could do something like that. You could say, well, I am publishing this data, but the only way I'm going to accept a connection is if you pay me to do that. Like you could do something like that. You could put an offer file on the connection, and then you would only accept the connection if there was a certain payment there. So you could do something like that.
I think that's what we would eventually see, especially for. I mean, you can get on Twitter and read people's tweets, and then people who actually have a good content. Some of them have subscriptions, so I think that that Chia gives us the bones to actually do that in a and I think is a very important. Uh, like you talk about putting everything into tokens for communication, and having a token like XCH and the aspect of Mojos in XCH that not only you can put information in and pass around on the internet in a smart coin, but also convert into other things via Tibetswap or whatever is one of the great innovations of uh, of this change in the protocol of internet communication.
Yeah. So in denial of service, the reason that you can achieve something like this is because making a connection to a machine is cheap, and most servers in a client server infrastructure will take a connection from anybody, right? Like they'll just say, "Yeah, I've got to accept incoming connections because if people want the data, like that's the whole point of me existing as a server is to give the data out to people that want it." So if you flood it with lots of fake connections, then it can be really cheap to shut down some system that's serving the data because it says, yeah, I'll accept this connection. And then it keeps accepting connections. And the fact that it keeps accepting connections eventually makes it so that nobody can get access to the data. So that is the fundamental sort of flaw in this client server public architecture. But if you were to think about something like, well, let's couple everything to some sort of a blockchain and some sort of a payment mechanism, then a server could say, well, I'm going to charge a nominal amount, like, I don't know, 5, 10, 20 cents. And you could say that, like, if I'm starting to get too many requests, like, my price is going to go up. So you could refuse a connection and say the price is now 50 cents because I'm having too many connections, and you either have to wait longer, or I'm not going to serve the data unless you pay me a certain amount, which makes a denial of service attack less effective because it puts a real cost on it. And it also makes it so that the person who's trying to make the connection has to do some amount of work before they do it. And that's why this whole idea of proof of work was really an innovation in Bitcoin, because Bitcoin could have been subjected to a similar type of denial of service, and proof of work was a way to fix that, to make some other computer do some amount of work so they can't just spam the database and put a bunch of garbage in there.
This is also in our episode of software and digging into this. I think that Lowry was beginning to understand that the way of networking and communication was not in the future was not to make everything so seamless and efficient that it wasn't a cost that registered on anybody, because this is part of the insecurity of our current networks. Um, and but I thought it was interesting, like his correlation with the proof of work of Bitcoin and the energy consumption costs of it. And in my mind, I kept wondering, how will concepts like proof of space and time, if it can get away from plot grinding and the use of GPUs and compression, how can that get us away uh, from from capturing that cost with the price of energy, or nation states, with their control of the price of energy, how can we keep this in the hands of the users? And so I still I I think that I think this is part of why the proof of space of time and the use of hard drives for the consensus is such an innovation. You know,
Yeah,
we
yeah. Speaking to that bit on software, it was this whole idea of this cyber dome, right? Like, how do you impose physical costs on computers so that they can't overwhelm a system, right? And it's that um, proof of work, proof of power wall that Bitcoin uses to protect itself, and that fundamentally can be used by saying, well, Bitcoin or Chia, like as the token, represents that proof of power, proof of work style representation. So it has a real world value to it because somebody had to invest a significant amount of money to get to the point where they could be awarded that amount of token. And so it holds that representation over the longer period of time. And that's why, if you think about how is it that Bitcoin keeps going up in value, it's because it's somewhat coupled to the hashing rate and the power consumption related to producing the next set of coins, and that there's a historical value for all of the hashing that's ever been done over time. And so Bitcoin has this retained value. And so if you want to use Bitcoin or Chia as a cyber dome of truth, it has a protection layer because not just anybody can write to it. Like, you have to pay money to write to it. And that can be extended in saying that, client server infrastructures can also be protected just by making you pay some amount of money and letting the server say, I'm going to set the price. And that's something that's really cool about the way that Chia functions, is you have this ability to attach a conditional payment, right? You can say, hey, I want to get access to this data, and I'm willing to put an offer on there that says, here's the coin that's associated with me wanting to get access to the data that you got, and if you accept the payment, then you'll give me the data back. And That's like a really cool concept of how you could you could protect a system from having a denial of service attack, and it is absolutely related to that whole idea of the cyber dome of truth.
I think Cyberdome of Truth should be a title of an episode. So, in our title, we have the dark web, and is data layer the dark web or what? So the answer to me seems to be no, that it's not the dark web, and that has to do with it seems to me to just be a cost web or a market web, as but not the dark web. And is that a better understanding of what's being created? And I say that because it doesn't, if it does both get away from location based identification and to be, um, the information is verified by the information and the distribution. However, there's not this notion of anonymity, or the anonymity um, may be fire gapped at at the vaults, or who is holding Chia.
Well, it's entirely possible that you could do that. So when we talk about what the dark web is, right? A lot of times it comes down to this type of a thing. We said, hey, there's these different protocols, right? There's HTTP and there's all this stuff. There's also this thing called Tor. So Tor is been used to produce stuff that has been canonically referred to as the dark web because it's a privacy protecting protocol. When you use HTTP and you set up a server and the server has an IP address, that IP address is known. Like you can fingerprint that IP address, like you can know almost exactly where it is. And this is why people would get notices when they were participating in BitTorrent, because fundamentally your IP address would be known to the swarm. And so, people who had content they were trying to protect, like people who owned those movies or whatever song files, they would say, hey, look, if you've been sharing this file or if you've been downloading this file using BitTorrent, we know your IP address. And so we can send you a letter in the mail and saying, hey, we talked to your ISP. Your ISP said that this IP address was your IP that was assigned to you at this particular point in time. And so we know that you were participating in this illegal file sharing. And so you need to stop that, or you could even be, levied with some kind of a lawsuit or a fine or whatever. And so Tor is a way to protect yourself from that. And Bitcoin uses Tor. It can use Tor. I think there's ways to, either use a straight IP address, but there's also ways to configure Bitcoin so that it uses Tor, so that when you're using Bitcoin, your IP address isn't necessarily linked to you. So this is a way that you could also use this type of concept in data layer, because remember, data layer has this, what are you putting on chain, telling people about how to get access to the data. If you put an onion link in there, a Tor onion link, then you wouldn't really know where the data was. And so it could be a mechanism for publishing information about, Tor routed style data.
Well, and I thought this is where it gets very interesting, that with your private keys, and it gives you the ability uh, to have access into specific data or specific identity, um, with the Chia blockchain, and yet your method of like personal traffic or your personal identification still could be obscured through onion or garlic routing. And I guess that also, is why I find the DID and verifiable credentials of Chia. Um, it seems that they're looking and thinking about making that process of verifying the identity of the viewer of information on the blockchain as well, but keeping that gapped from um, the method of traffic, or the on ramp of communication.
Yeah, these ideas of privacy are pretty important. So if you're going to have some kind of a decentralized identity, I think it's really important that it's a privacy protecting thing. It's like the ideas that Chia is throwing around here are somewhat standards based. Like there are major international bodies that have been thinking about ways to allow there to be an identity and then the selective revealing of information associated with that identity. And that's kind of what verifiable credential is. It's saying something like, I'm over 18, but I don't have to tell you my birthday. So if you were to be assigned a DID and then have a bunch of verifiable credentials, you could selectively reveal as little information as you want, but somebody else could trust it. And you're using something like Chia or Bitcoin as that distributed trust server. It's an immutable store of information, and you can hash things. And since things can be hashed, if you reveal the right piece of information, well, then you can know that it resolves to the right hash. Or you can use digital signatures to say, well, I've signed this piece of information with my digital signature. And so that way, you can trust it because you can verify the signature. So there's a lot of different pieces of technology here within the scope of what we would call Web3 that allow us to do some really interesting stuff. And I think it's where the internet needs to go fundamentally to restore some semblance of sanity, because right now we don't really have privacy. We don't have the ability to protect ourselves from denial of service attacks. And all of these things, I think, are going to start to come into play as people are building out this next generation of the internet. And we've been hearing Web3 as like the next generation of whatever, but like it really hasn't been coupled with a strong content distribution system. And so guys like Lowry and Michael Taylor are thinking about, well, how can you use blockchain to fundamentally solve some of these ideas and problems about data distribution, and how does this immutable database actually help you to do that?
So, and I think that's a maybe a great point to end this on, is because I hear Web3 thrown around all the time, and I think your points with regards to Web3 being about privacy um, and the verification of information paired with that privacy of those people accessing it is maybe the best understanding of what the goals of Web3 are.
Yeah, I think so. Let's call it good there.
All right, well, Grant, thank you so much. I feel like I have a much better understanding of the magic behind data layer now. So thanks, I enjoyed it.
See you tomorrow.